And now for the main course. So I'm so happy to have Dirk coming and talking to us. Some of you may know that he was a colleague of ours here in the Department of Engineering Sciences and Applied Math. He was not only an outstanding scientist, which of course he continues to be, but he was also an outstanding colleague and really someone with whom you could have wonderful conversations about science, society, and everything. I'm very excited to learn that he actually has a book, a popularization book on complexity in Germany that sadly is only in German, but I heard that there is a very good possibility that soon we'll have an English version, and I would very, very strongly recommend everybody to get it, because I have no doubt that it's going to be outstanding, because he's such a wonderful communicator, as you will see. Dirk has done outstanding research, and I wonder if he even has had time to sleep with all the things that are going on with COVID, because he has really written a lot of work and kind of participated in the discussion of what should be done and how we should be monitoring this epidemic. So it's really, really a pleasure for us to have him. It's also incredibly timely, because some of you may have heard that the Nobel Prize in Physics was awarded in part yesterday to Giorgio Parisi, who's a complexity theorist. And so this is a great time for complex systems and the idea of using the tools of complex systems to study crucial societal problems. So without further ado, let's all welcome Dirk, and looking forward to a great talk. Thank you.
All right, I guess it's my turn now to speak. I hope everyone can hear me. I'm going to start sharing my screen. It tells me that this will stop others from screen sharing, so I'm going to continue this.
Yes, go for it.
Okay, all right. Okay, you should be able to see my screen now. And before I start talking about my activities, first I want to thank Luis for his kind words and for the opportunity to talk at NICO, which is like coming home to me. So it's not to me, it's not just a regular scientific talk. It's like a talk talking to my family, and that's why it's a very important to me, also emotionally, to give a presentation at NICO. I briefly looked at the list of attendees, and I recognized many names, and I can tell you that I miss you a lot. And but I'm not going to whine now and cry about how much I miss you. Instead, I will be talking to you about some of the activities that kept me busy the past like 18 months or so, ever since that pandemic came about. A little bit about why this kept me so busy. In Berlin, I am at Humboldt University, but I also have a group at the Robert Koch Institute, which is kind of like the CDC for Germany. So the National Public Health Institute, where the stuff that I do there is essentially modeling infectious disease dynamics, things that I had already done also when I was at Northwestern, when back then in 2009 we had the H1N1 pandemic, and we were modeling and trying to predict how this spreads around the globe. And back then we didn't really have COVID on the radar, and all the people, the few people that do this sort of work, they are all very busy, and and I can tell you that I'm really looking forward for this to end so I can do something else. Now, when I initially submitted the title of the talk, I wanted to talk to you about a project which is very dear to my heart, which is a citizen science project, a data donation project, which I will tell you about at the end of the talk. But before that, I figured in order to fill the 45 minutes or so, I want to also touch on some of the other projects we've been doing. Now, one of the things I'm gonna stop sharing now and want to share something else with you. Just 1 second. This is a little clunky, but I'll try to get it to work. You should now see a world map. Now I want to start with a picture or a video animation, which we did, which is kind of a bird's eye presentation in fast forward of the pandemic and how it hit the planet. You can check this out at my group's website. It's a video animation which was originally created by Hiroki Sayama, which we made into this interactive tool, which kind of shows how the pandemic unfolded on a global scale. And when we look at this, we see it's very complicated. It's not like a spreading wave or something. It's very, very complex in terms of like the spatio-temporal pattern that it generated over the past 18 months or so. Let me go back to the presentation. And when we look at this more closely, we see, and this is a little drawing I made. I have to apologize that it's in German because it's from my book that I'll talk to you about at the end of the talk. But it doesn't really matter. I can translate it. So on the y-axis, you see the incidence in Germany, and on the x-axis, it's just time. And on a very sort of superficial level, we saw these waves, and they were different in Germany compared to the US and compared to other countries. But there was always this up and down. And one of the reasons for this is, of course, that there's this virus and it spreads. It feeds on our contacts and we transmit it from one person to another. And then the epidemic unfolds, or the pandemic, and then we react to it by non-pharmaceutical interventions, by policies, and by wearing masks, for instance. And that feeds back onto the dynamics. Then maybe the case count goes down and we become less careful. We open up again and the cases rise again. And so it's this back and forth interaction between the disease and our behavior that with which we react to it. And here's another drawing. Again, it's in German, but most of the words in it you can translate directly, and you can kind of see what it says. We have like the infection dynamics, which is on the bottom left, and it, whatever happens in this pandemic affects our psychological perception of it, risk perception, effective risk, trust in government policies, and resistance towards this, and it changes our behavior, which then feeds back onto the disease dynamic. So it's a very complicated feedback loop that is happening, that is generating what we observe. And so one of the things that we try to do is understand how the disease affects our behavior. And there's very little known about this empirically. So on the bottom line, what we need to understand are human contact networks, because it's unlike most people that traditionally, have a traditional view on epidemics or related phenomena and see it as sort of a population phenomenon. It's really a network phenomenon because the virus kind of feeds on our contact. So it's really something we need to understand in order to understand the dynamics of the disease. And if we want to understand how we reacted, on a pandemic, we need to understand how these networks change, affected by the pandemic that is happening around us. And it's really sad. And the biggest problem, in my view, is that we know nothing about contact networks, not empirically. There are many models that have helped us understand what might happen in a population, but really nothing is known about contact networks, the everyday contact networks that we participate in every day when we join this, go on the subway, when we are in school, when we are at work. Only very, very little information is known about these networks, which make it very hard to understand how a pandemic unfolds on that scale and how we could contain it. The other thing that matters is how we move. It's the pandemic, and that's implicit in the word, is a global phenomenon. and it becomes a global phenomenon by us going from A to B. For instance, on this air transportation network. And usually in every one of my talks for the past 10 years, I show at least one version of this figure because it factors in how, the dynamics of a pandemic unfolds. So, but also these networks, our mobility networks, are affected by an event like the COVID-19 pandemic. And I'll tell you a little bit about this in a second. So one of the things, one of the projects that we started in April 2020 was a project in which we tried to actually monitor how some of these behavioral dimensions change in response to the pandemic. And so one of the things that we kicked off is the Mobility Monitor project. And if you can go to this URL, you can also just Google it and see what we did there. I'll show you how this works in a second. So part of this is an analysis of how worldwide traffic on the global air transportation network was affected by the pandemic. So what you see here, I'm sorry, the x-axis doesn't have any labels, but it's the past 18 months and it starts in April or March 2020. And what you see, how many seats were booked on the air transportation network before the pandemic and how it dropped down in April 2020 by a substantial amount. There are three curves in this. It's kind of short distance traffic on the air transportation network. It's like distances shorter than 800 kilometers or so, intermediate traffic and long range traffic. And you can kind of see that there was this massive decrease in a matter of weeks in April 2020, and then a slow recovery of air transportation on a worldwide scale up until now, but it hasn't fully recovered yet, and it's unlikely to recover fully. And you can kind of look at this data, every week. We looked at it every week and saw how it changed. You can compare like the United States to Germany, or countries like China that did a very good job containing COVID, and see, what happened, how the pandemic really affected our global connectivity as resembled by the worldwide air transportation network. And you see that some countries like China, for instance, they, in July 2020 had almost fully recovered their entire internal traffic, so like air transportation within China, but all the traffic that left China or went into China remained very low. And so there are differences if you compare different countries, but the bottom line is we're still in a state where this has not fully recovered, and these effects of the pandemic are long lasting. So that's just a very coarse scale of looking at things. The other thing that we looked at, which is also part of this mobility monitoring, is mobility on a finer scale. So in April 2020, two of the main German telecommunication companies gave us their data, aggregated and anonymized data of people that move about with their smartphones. So it's about 40 million people that we have in the data set. And using this data, we were able to compute how many people go from A to B, and A to B being, say, 2 counties in Germany. We have this on a finer scale too, but essentially it doesn't matter how you look at it. What you get is, for the country, this is a picture of Germany, and the red stuff that you see is, every link resembles how many people go from A to B. And so every day. And we have this data resolved, in hourly, the temporal resolution is like by an hour. So we can actually also look at, what is, how many people move about in the evening, in the morning, rush hour, etc. All this. And one of the things that we found very quickly, this was an early finding in April 2020, and we published it and luckily made it to the cover of PNAS, where we compared the network in its usual sort of normal reference baseline structure compared to what it looked like during the first massive lockdown. And these are the two pictures that you see there. And one of the things that we found is that not only did traffic reduced, but also the structure of the network was massively altered. And so mobility really structurally changed when you look at it from a network perspective. So one of the things that we wanted to do is set up a monitoring system that is updated every day, where we can see how mobility changes on a daily basis. And so really set up this entire infrastructure of getting the data, analyzing it, putting it into a visualization, and that is being updated every day. So I just want to show you a little bit what this looks like, so you can get a feeling of this tool. So this is something I showed you earlier. This is the mobility monitor. So what you see here is a picture of the country, and the curve you see on the right is mobility as a function of time. And you can actually see, for instance, in the summer 2020, the red areas are actually areas where there was a lot more mobility as compared to the baseline of 2019. And the reason for this was just because people didn't go on holiday abroad anymore. Instead, they went on holiday on the Baltic Sea. So there was lots and lots of traffic here in this area compared to the year before, simply because people didn't want to go abroad anymore or couldn't during the summer of 2020. And it's even the case in the summer of 2021. So the same kind of behavior. But what's important is this area here. I'll talk about this a bit more in detail now. So let me go back to the slides, and you can check out this mobility monitor if you like, if you just go to our website. So that's what was one of the things that we wanted to set up, just to see, for instance, how policies, also regionally different policies, affect mobility, and therefore also affect the dynamics of the disease. So one of the early things that we looked at was mobility during the first lockdown. This was April 2020. And there you see in week 11, 12, and 13, actually it was March, not April, I'm sorry, how mobility looked like under normal circumstances. And then there were some policies that were put in place, and kind of the whole country was frozen because no one went anywhere. And you can kind of see this also when you quantify it. The black curve is like the regular mobility. It has a baseline. And then within like 2 weeks in mid-March, mobility dropped down by about 40%. Interestingly, because everyone was scared of this pandemic, no one knew what was happening, how dangerous this was. And the European soccer tournament was called off. And, in Germany, when this happens, something is serious. And so people were afraid, and they were very, behaving very well. The policies were put in place, and everyone restricted themselves. But then shortly after that, and you can see this, this curve moved back to its normal baseline value within a matter of weeks. Even though there were no, the restrictions that were put in place were not eased. These are the green lines, and it just moved back to its normal value much earlier than that. And you can kind of look at how mobility behaved during the past 18 months. So this is a very recent plot. You can see the massive lockdown effects in March and April 2020, and then in January 2021, when we were hit by the third wave, and how this then slowly recovered. There's always this drift back to the baseline. One of the things that we showed is that this may have had a massive effect on the dynamics of the disease when you think about the geographic proliferation of the virus, because of the changes in the topology of the network. Something that I found more interesting is not really the effect, the direct effect that mobility has on disease dynamics, but rather measuring mobility as a sensor for behavior in the population. One of the studies that we did also quite early on was because we were puzzled by this drift of mobility back to the normal baseline, even though the restrictions were not, they were still in place. And so we collaborated with a psychologist in Erfurt, another town in Germany, who did a very sophisticated survey, continuous survey study, and asked people about how happy they were with restrictions that were put in place. And we found that there's a strong correlation between compliance to these measures and the psychological or like the attitude towards it. And this was really seen in compliance on the dimension of mobility in the individual. So the solid curve, the dark curve is mobility, and the green curve are results from these surveys, and they were very much in line. Now, the other thing that I mentioned earlier, it's not only about mobility, but it's really also about contacts. That's something we really, really want to understand. And even though there's so little known about contact networks, there are some projects. It's very hard to do this kind of thing in Germany because of data protection laws. There are some projects that target actual contacts. And most of the technological tools that are used for this are cell phone based and GPS based. So there's a company in Germany, and they do this sort of experiment with GPS information and measuring actual contacts of individuals when they get close in space. Like what they do is they measure proximity networks, and we had access to this data and were able to, just like with the mobility monitor, set up a contact monitor project. And we just recently, just a couple of days ago, actually, we went online with this analysis. It's also part of this mobility project, but it's a contact monitor. So what this is the way it works. It's really like two individuals that move about. For instance, they go to the same grocery store, and the GPS information delivers information if two people are within a radius of a few meters. And when you do this with very many people, you can reconstruct an actual temporally highly resolved and spatially highly resolved contact network. And that's the sort of network you need to be able to look at in order to understand disease dynamics. Unfortunately, we don't have the information on the network. We only have the information about the number of contacts and the statistics that individuals have per day because of data protection laws. But even just looking at the contacts, actual contacts people have, and their statistics, for instance, the standard deviation in the population, we see that this sort of structure, our contact networks, are strongly affected by the pandemic. So this is again a long time series. Every day this is measured and computed, and you can see the orange curve it's just the average number of contacts an individual has per day. And it dropped down massively during the first lockdown, and then came back almost to a normal level. No, not really to a normal level, but a higher baseline, and then it went down again. But what's more important is to see, and that's very worrisome at the moment, at least in Germany, that it's drifting. It's not back to normal yet, even though everyone in the population perceives that they're behaving normally. And also the fluctuations in this are becoming increasingly larger. That's the green curve. It's something called the contact index, which is related to the standard deviation of the number of contacts. And it's really a measure for the variability of contacts individuals have as a function of time. So it makes a difference whether, if you go to a concert, for instance, or a club, then, you have lots and lots of contacts, whereas quite often you only have a few contacts. And so this kind of strong variability is an indicator that more and more transmissions occur, and also that super spreading events become more likely. And so we're expecting, by looking at this data, that the case
Dirk,
count in the winter. Yes.
can I interrupt with a question? A quick one.
Sure.
So an interesting thing about this variability, is it dominated by sort of a tail kind of thing? So there are some individuals, a small number, that have just a gigantic number of contacts, or it's more like a bimodal situation in which you is it a tail thing?
It's a tail thing.
Okay.
Fairly clear that it's a tail thing. That it's the distributions have a very long tail, and the variability is actually quite large, and it's not a bimodal thing. So
and it's very interesting how the drop occur, right? Because you are really chopping the tail to a huge extension, right? Those are the people that are most affected.
Correct. And so that's why we think that in the summers, when people avoided large groups, or groups in general, that this had a massive effect, because everyone was surprised, for instance, how the case counts were low, and no one really understood what was happening. It's slightly different in 2020 when we didn't have the Delta variant around, but for some time also this summer, people were surprised that, it wouldn't take off even though Delta was around. But my gut feeling is, and there's more and more evidence, that it's really the structure of the group size distribution of groups that we participate in. And you can see that in the summer now, there's these little spikes that you see with the green dashed line. These are weekends. And so weekend variability is very large. I don't know why that is yet, but in general, the variability increases. It's not where it used to be. Look at the very left of this plot. It's much, much larger under normal situations. Sports event play a role, when you have, many, many contacts with lots and lots of people. So we're not there yet. And even though people, at least among policymakers and the general opinion in the society in Germany, is that we're pretty much behaving normally, except for everyone's wearing masks still. And so
sorry to interrupt again.
Yeah.
You don't have any information about if the contacts are indoor or outdoor, right?
I don't, but the company that collects this, they do. But I don't.
It's a pity, because it would still be aggregate, right? And it would be extremely helpful.
And so, I'm trying to push this a little bit. And in the last part of the talk, I will talk a little bit about data donation, where we can participate in projects like this and are willing to share this kind of information, because very many people are indeed willing to share this information. And we can learn a lot about this, because at the end of the day, this whole thing is poorly understood because we know very little about our contacts. Okay. Can I continue? Because then I will come to the data donation project, which is very dear.
Yeah. Sorry, I just got really curious.
So let me talk to what was initially announced for this talk. That's the data donation project. It's a project which also started in last April in 2020. And it's kind of a dream come true, because prior to this, I was thinking that in public health research, it would be really, really, really good to have an infrastructure where individuals in the population can donate data that is collected by their smartphone or other wearable devices in order to understand disease dynamics better and behavior better. Because at the end of the day, it's, the pandemic is not a virological phenomenon, it's a psychological and behavioral phenomenon. And some of the problems that emerge, at least in Germany, is because the superficial opinion is it's a medical and virological phenomenon, but it's not. it depends on us, the host, and on our behavior, at least how incidence evolves in a population. So we need to understand behavior. And the data donation project is targeted at understanding this a bit better. Let me tell you what this is about. So in early 2020, there was a paper that came out by the people from Scripps, Eric Paul, Steve Steinhubel, and Jennifer and Nathan. And they showed that by using physiological data that is collected by wearable devices like smartwatches and fitness tracking devices, one can, if you record this data for a long period of time, detect whether a person has fever symptoms. And in a population, if you see statistical deviations from what you expect from the baseline, you can detect fever in a person, and therefore, potentially in real time, an outbreak of an infectious disease that generates fever as a symptom. So when we saw this, we figured, well, this was early 2020 and fever was a symptom of COVID. So why not do something like this as a digital epidemiology tool published by the Robert Koch Institute, by the German Public Health Institute. So with a company that did this, we got together. It's a startup, a digital health company in Berlin. They're great people. They had all the infrastructure for this, and I have to apologize. This is again a slide all in German, because typically now I give these talks in German to people that are interested in public health in Germany. But you can see from the picture, it's really an app on your phone, and it uses smartwatches like this one combined with the app to donate information about your physiological signals, like your resting heart rate, your sleep patterns, or your activity, which, for instance, the number of steps you take every day. And so we started this, and the idea was to collect from as many people as possible information like this. So the green line is the daily steps over, like, for some random person that is part of the donor family. The number of steps an individual takes every day. And the red line is the curve for the resting heart rate. And you can kind of see for this person, there's a typical baseline, both for the number of steps and beats per minute and the resting heart rate. Resting heart rate is your heart rate when you rest. And these smartwatches, they can measure if you're resting, and then they measure the heart rate, and we get this data point every day for all the donors. And the idea is simply that when you have a curve like this one, for instance, or let me skip this one. No, let me show you this one first. So here's a weird little thing for a person that has a baseline resting heart rate and a baseline step count. And then on this weekend, which is in red, both resting heart rate and step count go up. So this person probably on the weekend did like a holiday or a hiking trip or something that elevates resting heart rate and step count. It's very typical to see this in some of these patterns because people do different things on different days. Now, we were after specific signals that looked like this. So these are two trajectories, or like two time series of resting heart rate that for the person on the top went down for a couple of days and the resting heart rate went up. And likewise for this other person on the bottom. So one of the things that is, from this idea of the paper that appeared in early 2020 by the Scripps people, is that when this happens, there's a higher likelihood that the person is sick in bed and has a fever. And of course, you cannot measure this definitely for every person. But when you have a large population, you can see if this kind of thing happens more often than you would expect, then there might be an outbreak of some infectious disease that generates fever in the population. So that was the wild idea we had in early 2020. And then this thing was released, and there was, in the national news, advertisement for it, and in a very short period of time we had 500,000 users, which is really crazy in a country like Germany where everyone is really into data protection. But I was really surprised by this because these individuals, even though it's anonymized and aggregated, they donate their vital information to us. And so it became one of the largest projects of this type, where we have data of this 500,000 Germans every day. And now we've been collecting this for 18 months almost. And it's a treasure. And I'll show you what we did with it in a second. But the first thing we computed is a map of like the number of donors per population. And it's kind of sort of a sanity check. And we saw immediately that there are cultural differences between East Germany and West Germany, for instance, because in West Germany, there were a lot more people per person that participated because, in my view, the Robert Koch Institute is a federal agency, so it belongs to the federal government, and trust in the federal government is less in East Germany. So that's my theory, but I don't know if this is the reason. And then we looked at some properties of this to see what are the biases, etc. So there are more women participating than men with their smartwatches. The distribution of age, it does not reflect the census data. This is something we have to take into account when we make quantitative measurements. Interestingly, there are younger women in it and older men. I don't know why this is. There are different theories about this. Oops. And then one of the important aspects of this was, because it's a data donation project, we figured, and we're just passively reading this data of the individuals, which we don't know, we cannot communicate with them. It's just that we get these data streams. Is we wanted, part of the project was a very open discussion about the results and our progress. So we started a blog about this and have like various analyses that we had published, every few weeks. We also just progress, intermediate results. We wanted to have these donors on board to see that, that we're trying to do the best with their data that we can, and also show everyone, what we tried, what didn't work. So just to keep everyone informed, to have like a sort of a glass lab where everyone could walk in, because, to have them participate, the donors, in the project. And so you can check out this blog. There's an English version of it, and you can see the different steps that we took, and also the journey that we walked with analyzing this data. The main reason for this data was detecting fever. And in Germany, there are various, the short time predictions about the time course of the pandemic was very, very important for policymakers. Where are the turning points? Is there going to be a third wave? That sort of discussion. And one of the things that we wanted to do is to have this process, this entire process of the data collection, the filtering, the pre-processing, the analysis tools, the machine learning algorithms that work on detecting these signals, and the visualization. All of this had to be automatic and end up in one figure, which is the fever detection, or the nowcasting. So which is like the short-term prediction of what the case counts will do. And so this is a screenshot from this fever monitor, or the nowcast monitor, which is updated regularly on the web page. So this was a lot of work getting to this, because there's so many micro steps involved and so many things where we failed to do something, but finally it did work out. But the thing is, why I found this interesting is not only it was motivated by COVID, but there's so many things we can learn about health that are beyond COVID. And so let me just show you a few screenshots from some of the collateral analyses that we did while we were looking at this data. So one of the things we had to do is look at resting heart rate. And I said, why not compute a map of the resting heart rate in Germany? It's fairly straightforward. You just, compute the resting heart rate of all the individuals, you aggregate this, compute the average, and then you have a map. And you immediately see there, the variations that you see here are not fluctuations, they're systematic. For instance, we saw that in the former East German federal states, the resting heart rate is higher than in West Germany, except for in larger cities. We don't know yet why this is. Is it socioeconomic? Is it food? Is it age distributions? So we don't know this, but we just haven't had time to look at it into it yet. But it's fairly straightforward to do something like this, and it doesn't answer any questions, but it makes you ask new questions. The same is true for the daily step count. So this is a daily step count map, and you see like these dark green spots in the middle of Germany. These are holiday areas, mountains where people go on holiday and then they hike, so it's not so particularly interesting from a public health point of view, but it's things that we see. One of the things that is quite interesting that we saw actually, comparing 2 weeks in May 2020 and 2021. There's a big discussion about the long-term effects of COVID on the population. There's long COVID, the effects that a COVID infection has on individuals in terms of, brain fog and other things that a COVID infection may induce. But there are also other long-term effects. One of the things that we saw in the data is that, for instance, the resting heart rate in people increased only by a beat per minute, but in a population this size, this is quite a lot. So it's quite systematic. The bars that you see are the different federal states. There are quite substantial differences, again, between East and West Germany, like I said. But one of the things that is quite universal is that the resting heart rate in 2021 went up. Also, people gained weight. And so it might have something to do with this, but this is certainly one of the long-lasting effects that COVID had. And it can only be addressed, like in this data set, because we have, for 500,000 people, these very, very long time series of their physiological data. One of the interesting aspects, which I haven't discussed yet, is sleep. Sleep is turns out to be a very valuable data source. One of the things we also found is that comparing the sleep in these 2 months in 2020 and 2021 is that people sleep less. And we feel, but we're looking into this at the moment, that the lack or the decrease in sleep duration is not only substantial, but it could be related to psychological effects, people getting worried, many people having lost their job, not being able to handle kids because they're not going to school. So it's quite systematic also on the sleep dimension, what this pandemic has done to people. We are doing a number of projects concerning sleep. This is just sort of a sanity check. We can do like age stratified analyses, like people that are older sleep less and they also go to bed earlier, that sort of thing. It's all stuff we can see in the data. This is not particularly interesting. It's just to show you that we can also ask questions like this. One of the things that I found also interesting is how differently people sleep in Germany, in East and West Germany. Again, so you can see an East-West difference here, which is not entirely caused by different sunrise times in the East and West. You can see Berlin, it's the dot on the right. It's behaves more like West Germany. So it's almost like you see traces of still differences in culture even after 30 years after reunification. So the imprint of this is still visible even in the sleep data. There are also funky things like social jet lag, which is something that you can compute the difference in sleep pattern between weekdays and weekends in different areas in the country. So looking at the mid-sleep time difference. So when people have the middle of their sleep, they go to bed at one time and then get up at another time, and the middle is the mid-sleep. It's like sleep researchers look at this for some reason. They like looking at this, and you can look at the differences per individual during weekdays when they work and during weekend when they can sleep late. And for some reason in the South, people don't have this much of a difference, whereas in the Northwest, they like sleeping late in the weekends. So we don't know why this is. We know nothing about this. It's really has only become possible to look at this using this data now. One of the things, I apologize again for this being in German again, is a study that we're trying to do between rural or like suburban and urban lifestyle, because of when it comes to sleep or activity or resting heart rate, to see what kind of socioeconomic factors play a role in these health dimensions. And we see that, like in the top histogram, the red is a city. It's a resting heart rate and distribution for people that live in a city, and the purple one is people that live outside of cities, and the resting heart rate is larger, which is usually an indicator of less good health. And there's not much difference in terms of like the mobility, how active individuals are, but the sleeping, which is the bottom histogram, is quite different in the city, and which is in red, and the light blue is outside of cities. The people go to bed earlier when they live, in the country, and there's, light pollution. All these sort of things play a role, and we're trying to look into this more closely now using this data. These are all questions that we address outside of the COVID context. Now, this word is German, and it says Datenspende, which means data donation. Next week, we're releasing a new version of this app, which is going to be a game changer, because we can then also talk to the donors. At the moment, it's a passive measurement technology, but starting next week, we can run live surveys to these 500,000 donors, and ask them questions, and we'll have the answers immediately. For instance, we can ask a question: did you have COVID? And if so, when? Which makes sort of the machine learning algorithms that detect signals in their heart rate that are COVID specific much, much better and more accurate. And we can ask all sorts of questions concerning behavior, contact behavior, social dimensions, etc. So it's really now, with this version, we can integrate the physiological information with the behavioral information. I think that's going to be very promising to do this. One of the things that we really want to address here is long COVID, because it's known from this study. This is again a paper from the Scripps people, a figure that COVID can have long-lasting effects on resting heart rate, and we really want to see if we can detect this also in the data. And so I've come to the end. Here is, again, like I mentioned earlier, and Luis mentioned this. This is the book. The reason why I had like all of these drawings in this talk, and they were all in German because they were taken from this book. It's a different topic. It's all about complexity, and I know Bill Cath is in the audience. I saw your name, Bill. I'm going to send you a copy because I know your German is excellent, so you can read it. And I will send one to Luis and Julio too. But then you guys have to wait until it's translated. But the reason why the drawings are in German is because they were taken from the book. And this is my favorite one that you see here. It's about Komplexität, and how it's in the book chapter, it says doing research like a fungus, because it connects to everything, because a fungus, in the forest has like this network of filaments that you don't see, but they connect everything. So complexity science is like doing research like a fungus. So with this, I thank everyone for your attention. And I hope you enjoyed the talk, and it was sufficiently interesting for the NICO crowd.
So Dirk, thank you so much for such an exciting talk. There is a question from Christian Webb. When considering the distribution of behaviors rather than mean behavior, do the typical risky behavior distributions resulting from cell phone, air traffic, and biological donated data match? Do they change in the same way for different periods of the pandemic in Germany? And also another question, can you correlate properties of these distributions to contagion dynamics better than the mean behavior? If so, which properties?
I have to smile because should I go and answer the question? There's so many of them.
Yeah, so my try to be short,
Yes.
kind of just gives some little hint because I'm still hopeful that there will be another question too. And I just want to get some chances to people and yeah.
So, and hello, Christian, it's good to hear from you. And I'm not surprised that you asked so many questions because you're a curious guy. I don't know if I can answer all of them. So there's actually quite, very little known about the distribution of behaviors. We don't have any information on it. I mean, at best, you can have like for the contact patterns, we only get this information, which is like the mean and the standard deviation because of the privacy issues. We hope that we will be able to address distributions with the new version of the data donation project, but there's really very little known, except for information about surveys. But even that is quite shaky.
Okay, we have a couple more minutes if someone wants to be brave and ask a question. I'm always very eager to see students asking questions. If we were all live, I would be actively shaming you for not asking questions and pushing and annoying. This is much less effective online.
While the students get their questions ready, I might ask one, Dirk. Do you think that your data donation project, has that been tried in the past? Have you specifically worked with that? I'm wondering if the pandemic made people more receptive to this kind of a donation.
It definitely has. So that's a clear yes, because this sort of thing is, so in Germany, it's very hard to convince people to do this. But in April last year, everyone was super scared and everyone was super compliant and everyone was trying to help. And so that's kind of the feedback we get from the donors. They say, I don't care, all these, Fitbit and Apple, they use our information anyway. And so why not donate it to the researchers that really can make sense of it? And the Eric DePaul and the Steve Steinhubel from Scripps, they have also done a data donation of this sort. In fact, they mentioned us in one of their articles because everyone, including them, was surprised that in Germany you get 500,000 people to do this simply because the head of the Public Health Institute, my boss, advertised it on television, and everyone participated. And in fact, the people that participate, they want feedback. They want to interact with us. So it's really, I think it's a model for the future where, it's clear that you can do citizen science. You have to be very transparent. It was instrumental for the success to have the blog where people checked out our progress. It's as if they walk into our lab.
Bill has also a question.
I know. Bill, yeah. Okay, so I have to read it. I cannot hear Bill's voice. Hi, Bill.
He sounds the same.
I'm sure. Regarding the change in resting heart rate, has the average age of your donors, very good question, stayed the same over time? I've read that average heart rate increases with age. True, but that's fixed here. So the groups are chosen so that also weather plays a super important role, that this has no effect. So we have to be very careful in the comparison, so it's systematic.
Rosemary wants to follow up on Bill's questions. So Dirk, the usual suspects just don't want to let you
Rosemary. Hello, Rosemary. Yes, that's a good point. That's a very good point, actually. We haven't checked that. That's a very excellent point. We should check that. So I know it does affect my heart rate, because I when I go in my institute, I have to walk stairs and I have to wear a mask, and then I like almost faint when I reach my office.
I want to thank Dirk again for a great talk. It was so cool to be with you again. Hopefully sometime soon we can get you here in person. Maybe we can have an event for the release of the English version of your book. That would be very cool. So just putting that in the back of your mind for us to organize. Yeah, thank you.
Yes, it was great. And I will definitely, my next presentation at NICO must be in person. So that's it's like the silver lining. I'm looking forward to that.
Hi, everybody. Bye, Dirk.
Thanks, everybody.
Bye-bye.
Have a great rest of your day. Bye.
You too. Bye-bye.